So when you're graphing a linear inequality, you graph the line like you normally would as long as it's in what format? What does the equation have to look like? Y equals mx plus b. But instead of an equal sign, it has a less than or greater than sign. Good. So instead of an equal sign, it has a less than or greater than sign. One thing that I didn't really look carefully at, but these should be different. What kind of line should number 4 be? Should it be a dashed line or solid? Solid. What about number 5? 5 should be a dashed line. So I wasn't really looking that carefully for those, but just remember that on a test or a quiz, okay? Speaking of which, your test is going to be Friday. Do not forget that. All right. Tomorrow. Yes, tomorrow. So we will do a review for the first half. All right, we're going to do a review for the first half, and then we'll do your test during the second half. What? It's like a little shorter because it's Community Friday, but not like significantly shorter. Oh, sorry. Yeah, it's a Monday, Friday. He was wrong. It's a Monday, Friday. Because whenever we don't have school on Monday, it's a Monday, Friday, that Friday. No, it was Martin Luther King Day. We've only been here one day this week.
We have?
Yeah. I know. Well, okay, yes, we've been here too, including the fact that you guys are here today. All right, so then you graph it when it's in y equals mx plus b form or y is less than mx plus b form. How do you decide where to shade it? How do you decide where to shade it? So let's do number 4 as an example. So we started up here at 4, and then the slope is up 1 over 1. But because we ran out of room there, a lot of you guys did this, which is great. Went down 1, left 1. And then there's your line. It should be a solid line in this case. All right, and then you either have to shade above it or below it. How do you know where to shade, Esmeralda? Plug in 0, 0 for x and y, right? So if I plug in 0, 0, 0 less than 0 plus 4, what's 0 plus 4? Is 0 less than 4? Yes, 0 is less than 4. That means wherever 0, 0 is, that's the side that should be shaded. So since it's underneath it, we shade right here. Okay, if it had not worked, where would you shade? Above it. All right? Now, why can't you just say it's always going to be under it or it's always going to be above it? If the slope of the line is different, sometimes it's hard to tell what under it means, okay? So if the line were like this, it would be hard. Well, that's not a straight line, but imagine that we're a straight line. It would be hard to tell really like what was under since it looks like left and right. So rather than trying to memorize, if it's less than and the line is horizontal, draw below it. It's easier to just plug in 0, 0, see if it works, and then color either in the 0, 0 part or outside of the 0, 0 part. Now, the only difference is if the line goes through 0, 0, obviously you can't plug in 0, 0 because it's on the line, so what should you do? Just pick a different point. And again, typically you want to pick something that's easy, so I would pick like 1, 1. All right, then if 1, 1 works, color that side. If it doesn't, color the other one. Okay? Now, what we're going to talk about today is how to do systems of linear inequalities. So again, we've talked for a couple weeks now about systems of equations. What is a system of equations? Brendan. 2 equations that are related to each other. What do you mean by related to, or what does he mean by related to each other? They have the same answer and they have the same, not necessarily slope. They intersect at a certain point. What variables do they have? If one of them has x and y, the other one has to have x and y. It can't be like x, y, and AC, right? Because then you couldn't solve it. Because remember, system means that they work together. So you need multiple equations so that you can solve them. So what we're talking about today then are systems of linear inequalities. So again, a system is multiple of something. So in this case, it's multiple inequalities. If I say, is 2, 1 a solution to this system, what would you have to do? Plug it into which one? To the x and y in which inequality? The top one, the bottom one, or both? You have to do both, because if it's a solution to a system, that means it's what? It's a solution to more than one. It's a solution that works for both of them. So 2, 1, if it works for one and the other, then it's a solution. So let's put it into the blue one. Where does the 2 go? And 1 goes in the 1 less than negative 2 plus 4. What's negative 2 plus 4? 2. Is this true? 1 is less than 2. Yes, good. All right, now the red one. Y is less than or equal to x plus 1. What do we plug in for y? 1. What do we plug in for x? Is 1 less than or equal to 3? Yes, 1 is smaller than 3, so it works. So is that a solution to this system? Yes, because it works for both of them. All right, that's a solution to the system because it works for both of them. If it only worked for one of them, would that be a solution? No. Okay, solution means that it has to be an answer for both of those things. All right, try this one. Try that one at your seats. All right, what does the first one look like? 0 is greater than or equal to 2 times, so that is 4. All right, is that true or false? 0 is greater than 4 is false. So then do I even need to do the second one? No. Is this the solution? No. All right. Okay, so if I want to solve a system of inequalities, so if I want to find all the solutions, again, do we want to do something where we like guess and check and try to find every single solution that will work, or do you think there's an easier way to do it? There's an easier way to do it. And again, if I ask you for all of the solutions, you would be here forever, right? Because there's an infinite amount of solutions to these system of inequalities. So how do you think you might do it? Think back to what we did to solve just one of them. What did you do to solve one of them? You graphed it and then found what? What did you do after you graphed it? You shaded. And what does that shaded area represent? All the solutions. So this colored in area, this green area, represents every solution that works. So that means, does the solution 4, 2, does that work? Yes, because why? It's over on the shaded side. Does the solution negative 4, 2 work? No. Okay, so without even having to plug it in, I know if it works or not, because if it's in the colored spot, that means it works. If it's not in the colored spot, that means it doesn't. Okay? So then what do you think we would do to solve a system of inequalities? Graph both of them and shade them in and look for a common spot. So take a look at this. So in this system of inequalities, we've got, does everyone see the blue one and the red one? Okay, so the blue one is shaded underneath it, so that's all blue. The red one is shaded underneath it, so that's all red. What else do you see? This would be hard if you were colorblind. What else do you see? You see red, you see blue, and you see... Oh, we're pretending this is red. This right here is red. This right here is blue. So this one is what? Okay, purple. So think back to your like art classes when you were younger. What makes purple? Blue and red. So what do you think the purple in here represents? A combination of both of them. So the purple represents the solution area. So for instance, under here, or this one that kind of looks peach but should be red, this right here is a solution only to the red one. Over here, this is a solution only to the blue. But down here, this is a solution to both of them. So that's the spot you're looking for. So then if it says, is negative 2, 3 a solution, you would go negative 2, positive 3, 1, 2, 3. Is this a solution to the set? No. What is it a solution to? The red one. Okay, so that's a solution to the red one, but not to the blue one. Therefore, it's only a solution to one of them, so it's not a solution. All right, can somebody give me another thing that is a solution? Give me a coordinate that is a solution. 0, 0 is a solution because it's in the purple. Okay, give me one more. 2, 1 is a solution. Good, give me one more. 2, -1. Perfect. All right. Is that all the solutions? No, there's a lot of solutions, right? Am I ever going to ask you to name all of them? No, because I don't have time for that. You don't have time for that, right? But this right here, this purple, you're giving me all of the solutions. Except you also have to imagine that does this coordinate plane stop right here or does it really go on? It goes on forever. Okay, so imagine that this space right here is infinitely large because it goes on forever all the way to -infinity, which is why I would never say, okay, list all of the solutions. This is how you represent the solutions, the colored spot. So how do we do that? How do we make this picture? How do we make this picture? Like if I didn't give you the graph and I said find the solutions, how do you think they did it? How do you think they did it when they made this example problem? Well, what do we have here? We have a, what is this thing? It's a graph, all right? What's on the graph? Coordinates, okay? And what are these things? They're lines, so they graphed the two lines, and then they did the shaded spot, and you just find whatever you have in common. So that's how we're going to solve these systems of inequalities. So first, you write everything in slope-intercept form. All right, so you put everything into slope-intercept form. So if you're doing these two right here, get them so y is by itself. This one's our red equation. Here's our blue equation right here. We didn't have to change the red one. We had to change this one. Then you graph the lines, you shade, and you find the purple stuff. All right, and the purple stuff, again, is whatever they have in common. So let's take a look at doing one together. All right, and again, you don't have to use red and blue. All right, I just use red and blue because it works together to make purple. So do I need to change, before I even start, do I need to change either of these equations? Yes. Which one? The second one? So the second one right now says 3x plus 6y less than or equal to 12. That doesn't work because the y is not by itself. So what do I have to do? I've got to get y by itself, right? How do I do that? What do I get rid of first? Good. So I subtract 3x. And what does that look like now? What do I have left on the left side? 6y less than or equal to, what do I have over here? All right, why did you do it that way instead of 12 minus 3x? Guillermo? It wouldn't be slope-intercept form. So it wouldn't be wrong, but it wouldn't be slope-intercept form. And then how do I finish? Divide by 6. What do I divide by 6 on the right side? Everything. So divide by 6, divide by 6. That means you do it twice. So this gives me what? Good. We've got y by itself. What's 3 divided by 6? 1/2. So it's going to be -1 over 2x plus what's 12 divided by 6? 2. Okay, there's my blue equation. And here's my red one. All right, who can come graph the red one? Y is x minus 7. Who can come graph the red one? Brendan? Good. How come your slope is 1 over 1? Or how do you know that? I don't even see a number there. How do you know that? How did he know that? How did he know to go up 1 over 1? Montrell? There's an imaginary 1 in front of x. Perfect. Okay. All right. Is that going to be a dotted line or a solid line? Okay, it's going to be a dotted line. All right, okay, so there's our dotted line, right? All right, that looks good. So I'm going to extend it a little bit further just so we have a good boundary there. Okay. What'd you say? That's okay, they look perfect. Okay, who can come do the blue one? Who can come do the blue one? So our equation is y is less than or equal to -1/2 x plus 2. Ashley? I know, they're hard to see. Good. And then, yeah, just do one more. Perfect. Okay, is that one going to be dotted or solid?
Dotted. Oh, solid.
Solid, good. Okay, so then the last thing we have to do is figure out our purple stuff. So in the red one, this says y is greater than x minus 7. So where do you think we're going to shade for the red? Above or below? Probably above. So that means 0, 0. Let's plug it in. So 0 is greater than 0 minus 7. What's 0 minus 7? Negative 7. Is that true or false? 0 is greater than negative 7. True. So that means red is going to be all the stuff up here. Okay, so red is all that stuff. Blue now. Looking at blue, y is less than, so that means it's probably going to be underneath. So 0, 0, let's plug in 0, 0. 0 less than or equal to, this becomes 0, 2. 0 is less than or equal to 2. Is that true or false? True. 0 is less than 2, so it's going to be all the stuff under here. So where is my purple spot? Right here. All this stuff are your answers to both. So I'm going to do that in black just so you guys can see it. So all this stuff right here is all the stuff that it has in common. Okay? So all of that is the solution to the system because it's the one that is in common for both of them. So, for example, is 0, 0 a solution? Yes? On a test or a quiz, what I'm probably going to do is ask you to name any coordinate that's in that like combined set. So you're looking for any coordinate over here. So if I said 10, negative 8, does that work? No. Okay, questions? Go try it. Okay, so when you're solving these systems of equations, you should be looking for that common colored part. So again, I'm fine if you color both of them and then somehow like highlight the actual common part. But keep in mind for a test or a quiz, I'm going to ask you for like a solution that works. So some ordered pair that's inside of there. So when you guys did number 1, I saw pretty much everybody get this one. So I'm going to put this one up. All right, so for the first equation, negative 2, and then the slope is negative 1 over 1. So we go down 1 over 1. Is this going to be a dotted line or a solid line? This one would be a solid line. All right, and then where would I have colored for this one since it's less than that? Everything underneath it. And again, to test that, plug in 0, 0. In this case, 0, 0 does not work, so then it's everything below it. And then for the other equation, we're starting up at plus 2, and then we go down 5 and over 1. And so our line is right here, and this is also a solid line. But in this case, now it's greater than that, so we're coloring to the right side of it. So where's the common stuff? Like this little triangle right here, which looks small in this coordinate plane, but in reality, it keeps going on and on forever and ever. So it would get wider and wider as it went down. So to pick out a point that's in here, you would say, okay, maybe something like 2, negative 5, because that coordinate is in there. So your answer on a test would be like 2, negative 5. Okay? All right. So can somebody remind me of the 2 kind of weird solution systems that we sometimes get? What are the 2 kind of weird solutions that we sometimes get? All reals or no solution. What do you think that might look like on a graph like this? What do you think, Guillermo? On top of each other, the colored spot would be all the same, right? And that would be for which one? All reals or no solution? Good. What about no solution? They would have nothing in common. There would be no purple. So for parallel, sorry guys. All right, so for something like this, we've got 2 right here. first of all, are they both in mx plus b form?
Yes.
So do we need to change anything? No, we can graph them right away. So for our first one, y is less than 2x minus 3. Where do I start that one? And then what do I do? Up to over 1. Is this a dotted line or a solid line? It's a dotted line. How come? Because there's no equal sign underneath it. There's no line underneath it. Okay, so there's my black line. And it tells me y is less than that. So let's plug in 0, 0. What's 2 times 0? Minus 3. All right, is 0 less than negative 3? No. So that means I don't color up here. Where do I color? Down there. All right, where do I start for the second one? Positive 2, and then I go, or I can go down to left 1. All right, and that's a dotted line as well. Okay, and it's saying it's greater than that. So again, if I plug in 0, 0, 0 greater than, what's 2 times 0? Plus 2? Is 0 greater than 2? No, so 0, 0 is not in it, so that means I color to the left side of it. And what do you notice here? The lines are parallel, and are you coloring on the same side or different sides? So that means in this case there is no solution. All right, there's no solution there because you're coloring in the opposite sides. What if it had been the other way? What if it had been y is greater than this and less than this? Then what would have happened? It would have been all reals because you would have colored the black in the middle and you would have colored the red in the middle. Okay? All right, so again, look out for those. Do you see them a lot? No. All right, you don't see no solution or all reals that much, but be able to recognize it when you do. We're going to skip this section of the practice because I want to make sure you guys have enough time for the exit ticket. So I would like you to do 1A, 1B, and then just do 3A, okay, on your template. So 1A, 1B, and 3A, go ahead and get started.